Hello everyone. Today we're going to build a Bitcoin wallet from scratch using C programming. It's not going to be a fully functioning wallet, but the core cryptographic foundation that makes Bitcoin work. I'm going to kind of show off a couple of things. So, Bitcoin wallet breaks down into like 4 or 5 different things. It starts with a private key. So, this is like a random 256-bit number. That's 32 bytes of pure cryptographic randomness. Think of it as a master secret that provides you to your Bitcoin, access to your Bitcoin. So you can never share this with people, and only you should have this private key once you create your wallet. The second step is a public key, which gets derived from the private key using SHA-256 elliptic curve, which points to XY on the curve, like on the graph. So then there's a public key hash, which hashes to SHA-256, and then RIPEMD-160, producing a 20 byte hash. This adds an extra layer of security. And then there's your Bitcoin address, final human readable address using base 58 check encoding. Includes a 4 byte checksum to prevent typos. So before we can start anything, we're gonna have to install some libraries so we can work. And if you're on Linux, then I'll have the commands down in the description of the video. But it should be sudo apt install libsync cp256k1/dev and libssl/dev. I'm on Fedora, so it's not gonna work. Anyways, after you install those libraries, cd into your directory where you're gonna work, and we're gonna make a directory Bitcoin bid. Go inside that directory. We're also gonna make a make file so we can compile everything in one simple way. So let's touch a make file. I'm gonna use Helix for this video. You can use any text editor you want. And I do have a pre-pasted make file. I'm just not gonna type it out here, but this will be in the description as well. I might link a GitHub video. I might link a GitHub link with all the files. So that'll probably be the best idea. Let's also touch our main file. We're going to keep all our functions. So I'm going to put everything in one file. If you want to split everything in directory and stuff like that, I'm not going to be doing that. So first we need to include our basic structure, which is all the includes, like stdio. We're going to need stdlib. Let's include string.h as well. Let's include SHA-256. Let's include OpenSSL. We need SHA from here. We need OpenSSL once again, and then we need the RIPEMD. And those I showed earlier in my little presentation. We'll also need OpenSSL's RAND. We can't use the one that comes with C language. It can be replicatable, and you can lose your money in your wallet. And if we're making a wallet, we want it to be secure and safe, for people to use. Let's define private key size. Set it 32. So one of the first functions we're going to cover is going to be generate private key function. So it's going to return an integer. Generate private key. It's going to take an unsigned character. It's going to be the buffer, because we're actually going to generate inside this function. So you would have to pass like in unsigned char priv, priv key. And you can pass that, and that'll be your buffer. So if rand bytes. And then we're going to generate into private key size of our private key, which is 32. If it's not equal to 1, we're going to print to std error saying fail to generate random bytes. So we're generating 32 random bytes and filling our private key up. And we'll return 1 here, return 0, fails. I missed the 1 here. Okay, so here's our generate private key function. And we're not going to use rand, obviously, to generate the random bytes because it's not safe. So let's continue working. I think the next function should be derive public key. So it's going to return integer, derive public key. It's going to take a const unsigned character, which is going to be our private key. We're going to take in the size as well. Size vector public key. Also size t for pub key length. So we'll start off by creating a context. We can use this function. Sorry for all the typos. It's been a while since I've made a video. K1 underscore context create. Then we're going to pass some flags like say 256 K1 underscore context sign. And then we're going to pass or 25 underscore context verify. Boom. And basically context create creates a context for us. Creates a SHA-256 K1 context object in dynamically allocated memory. This function uses malloc to look at memory. It is guaranteed that malloc is called at most of the once for every call of this function. You need to avoid dynamic memory allocation entirely. See the static one, but we're going to use the dynamic one. Let's create our public key as well with pub key. Open queue data structure that holds a parsed and valid public key, basically. So create public key for private key if not K256 K1 underscore EC pub key create. We're going to pass the context and the pub key. We're going to dereference the pub key here and then pass the private key as well. So if this doesn't error, if it does error, we're going to fprint to std error, and our error is going to be failed to create public key. Then we're going to destroy the context. Destroy and pass our ctx to it. We'll return 1 here. This is errors. Now we're going to serialize to compressed format, or 33 bytes. So let's create pub key length set it to 33, 256 K1, AC pub key, serialize. So we're going to serialize the pub key function. Serialize. We're going to pass the context. We're going to pass our public key. We're going to pass our public key length. Then we're going to pass our pub key. We're going to pass a flag to say that it's compressed. That's what we want to do. This function takes more. Oh, I misspelled serialize. There you go. So our output is going to pub key, our output length is our output length, pub key right here, and our flag that we want it compressed. So let's destroy the context. And pass CTX here, that's our context. So we're done with this function. Let's return 0. So our next function we're going to cover, it's going to be like creating the Bitcoin address. So we're going to need our hash 160. And we're going to create this function from scratch. We need to implement the hash 160 function. So we need to convert the public key into a Bitcoin address. And to do that, we need to hash it. So, okay, so let's continue working on the hash 160 function. It's going to allow us to convert our public key into actual readable Bitcoin address. We're going to take in a const unsigned char, which is going to be our input, size t, which is going to be the length, and unsigned char, which is going to be our output. So unsigned char SHA-256 result. Not 192, just SHA-256 digest length. I don't know why the 92 popped up. It's a different length. And what is the default length on this? Let's see. It is 32. So could actually use our private key as well. SHA-256 input length SHA-256 result. Then we RIPEMD it. And SHA-256 underscore digest length, and then output. So this finishes up our function. Very simple. Why we double hash security? So even one of these hash functions broken in future, an attacker would still need to reverse the other one. So if the SHA-256 is broken, you'll need to reverse the ripper mod. It takes our 33-byte compressed public key and produces a 20-byte hash. So now we need to create a base 58 encoding function, or so we can encode this. So this is going to be a pretty big function. First things first, we'll need our alphabet. So I already have a pre-pasted alphabet that I'm going to throw up here. Or actually, you know what? Let's throw that shit in the function. Oh yeah, we can leave it out here. So let's create this const char. That's the alphabet. And it's missing a couple letters, so it's missing one. It's missing an L. I forgot what 4 letters it's missing actually. So it's missing a 0, it's missing a capital O, capital I, and a lowercase l. So that's the base 58 alphabet. Now we can create our function. So I'm not gonna explain exactly what base 58 is. You guys can look it up, but this is what Bitcoin uses. And this is how we're gonna be able to actually see um our address and make it readable format. Um, so we're gonna take in our cons char input size t length. And that's it. So we're gonna count loading zeros or leading zeros. Sorry. And 0 underscore count equals 0. So while 0 underscore count less than length and input 0 count equals equal to 0 0 count plus plus. So let's allocate enough space size t size equals length times 138. We can use less, but I'll use 138. 100 plus 1 unsigned char times temp equals, we're going to use calloc size 1, and then we're going to do the output char output equals calloc size plus 0 count plus 1 and 1. Hopefully that's the right size. Now we're gonna convert to base 58. For size underscore t I equals 0, I is less than length, I plus plus. So n carry equals input I 4 and j equals size minus 1. J is less than or equal to 0, or bigger than or equal to 0. J minus carry plus equals 256 times temp value temp j equals carry divided by 50. Sorry. So this converts our number to 258 using the alphabet. Now we're gonna skip loading zeros in temp and start with 0 while start is less than size and temp start 0 start plus plus. So let's add 1 for each leading 0 byte for and I 0 I is less than 0 count I plus plus. Then we're going to do our output I equals 1. This is going to replace all the ones. Then convert to base 58 characters. For and I equals 0, start less than size, start plus plus, I plus plus. output is going to be 0 count plus 1 plus I equals base 50 alphabet temp start. And we're going to need to free our temp. And let's return the output, and the output being our function. So this is a classic base conversion algorithm. For each input byte we added to the carry. For each position in temp, right to left, multiply the existing value by 256 right here. Shifting up one base, 256 digits, 256 digits. Add the carry, store remainder after dividing 58. Pass the coefficient as a new carry, So then we build the output, starting here. I'll add 1 for each leading 0 byte in input, just keep loading zeros. In temp, map each temp digit to a base 58 character, which happens here. And boom, we have a Bitcoin address. So now let's create the complete address generation function. So it's going to be char create Bitcoin address constant sign char random pub key size t pub key length. So let's do unsigned char hash. Use the digest length right here. Sign char version hash is gonna be 21. And sign char checksum full SHA-256 digest length. An unsigned char final address, which is going to be 25 digits long. So step 1 is hash 160 of public hash. So we're going to call our hash 160 function. We're going to pass our public key. Pass our public key length. Then we're going to pass our hash, which is right here. So step 2, we're going to add version byte. So 0 x0 for mainnet, and then 0 0 1 for testnet. Version hash 0 equals 0 x 0. So this makes sure that it sets the hash at zero, indicating that it's actually the main net and not the test net or any other net. Copy version hash +1 hash 20. Calculate checksum. First 4 bytes of double 256. Right, so we're going to call SHA-256, pass the version hash 21 checksum full. We're going to call SHA-256 again on the checksum full now. Using SHA-256 digest length and the checksums full. So now we need to append checksum. Read mem copy here. In final address, adding version hash and 21. Then we're gonna mem copy final address plus 21. and checksum full 4 because it's 4 bytes long. And then we return a base 58 encode. Turn base 58. There you go, base 58 encode. It's going to be final address. And the length being 25. So after building our final address, we finally base 56 encoded, which is our function right here. So what happens here is hash 160 gives the public key, which is 20 bytes. We add version bytes for mainnet, P2 PKH addresses, making it 21 bytes. So then we calculate the checksum, double SHA-256 of those 21 bytes, take first 4 bytes out. Then we concatenate them, we add them together. 21 plus 4 bytes here, which is 25 bytes total. 21 plus 4 is 25 in total. So the checksum is genius. It prevents typos when entering addresses. If you make a typo even on one character, the checksum won't match. So the wall is going to reject it. Or our wall is going to reject it. So now let's add the main function and utility functions, like printing hex out. Void print hex. So printing the hex out basically is what lets us print out our Bitcoin address to the terminal where it's readable. So we're going to do print f string label for size t 0 to x data then print f new line. Go. Now let's make our main function where all the magic is going to happen, where we're going to be able to create our address actually. So let's do unsigned char private key, and we already have a preset length. Let's do unsigned char public key. It's going to be 65 digits long. Do a size t pub key length as well. Printf Bitcoin wallet generator. Whatever, doesn't matter really what you want to put here. So let's generate our private key first. Pass our private key in. I have to make some. So we return 1 if it errors. Now we have our private key, and we can print it to the console using our print hex function. We need to pass our private key, and our private key size. Whoa.
I didn't understand that.
That's weird. Private key size, there you go. So now we need to derive our public key. We already have a function for that. Pass a private key here. password public key, and dereference our pub key length. Turn 1, if it errors, not going to print anything to the console, then we can print X pub key compressed pub key length. Now we create our address. Create Bitcoin. Okay, so we create our address. Create Bitcoin address. These are all homemade functions, you know, we just made them. Public key, pub key length, printf, Bitcoin address /s here. I suck at typing today, I'm sorry guys. We'll pass the address, and we need to free our address when we're done with it, and return 0. So this completes our function. I mean our wallet, our little mini wallet. So let's write it here. Let's type in make, missing a separator. Hold on. So after messing around with the make file, I actually fixed it. I'm gonna post it down in the description, so everything should be in the description. Let's leave out of the file. Already pre-made this, but all you have to do is type in make, and there we go, we get our wallet. So let's run our Bitcoin wallet generator. It's weird. So our generate private key doesn't work, I believe. So there were a couple errors in the code. Go ahead and open the code back up. I messed up in this function right here, in the checksum. This isn't supposed to be 192. So hopefully there's no more 192s or anywhere else. 192, nope. And then we need to remove all these exclamation marks because our code is running with this differently. There you go. So let's make, and then run our wallet, and there you go. We get our private key, we get our public key compressed, and we get our Bitcoin address. So we were to let's go ahead and open up our Bitcoin Explorer and paste in this address and see if it's live. There you go. It's on 2 blockchains, so there it is. So this address isn't verified yet, never had a transaction on it or anything like that. So let's also open Electrum. I have a couple wallets here. Let's create a new one. So we're gonna choose the import Bitcoin addresses or private keys, and grab this private key right here. Actually, it only accepts HG wallet, so we can't do that. But it does work, so it does work for sure. So thank you everybody for watching. Leave a like and subscribe if you can. Hopefully in the near future, I'm going to be making more videos about this. And just so you remember, this is not a wallet. It's only for educational purposes. This is not like a fully working wallet. You know, it doesn't have any security handling to prevent like key leakage things, proper key storage, you know, with encryption. Doesn't have the BIP32, doesn't have BIP39, doesn't have BIP44. You know, never store private keys in plain text and files is what we're going to be doing. Any sort of wallet creation or anything that has to do with Bitcoin. the main purpose is of people not losing money. And if you guys want to, we'll kind of make a interface for this, maybe in GTK in the next video, and we'll make a fully working wallet where you can send and receive Bitcoin. And I feel like that'll be a great idea. So thank you everybody for watching. Have a great day, and I'll see you in the next one. Bye.